Hi everybody, we're going to talk about graphing linear inequalities today. We're going to have a couple different kinds. Let's look and see if you, I'm going to show you first what linear inequalities mean. What we're doing when we're talking about linear inequalities, we're going to have, instead of having equal to like we did in an equation, we're going to have the less thans and greater thans. Those are what are going to be involved in linear inequalities, and so we're going to be graphing those. And when we graphed a linear equation on a line, it looked like this one down here. So here was an equation, it had an equal sign. We either made a table, or you did x and y intercepts, or you did slope and y-intercept. You found the points, you connected the points. We graphed. With linear inequalities, we're going to have something that looks like this. We're going to have some shading here. You notice some shading. Notice this line is dashed. Here's some clues. If you have to graph a linear inequality, first of all, we need to plot points for the line. And we're going to plot those points just like we plotted points in regular equations. Two, we're going to connect those points. And if you have less than or greater than, you're going to connect with a dashed line, like this example to the left. If you have less than or equal to or greater than or equal to, we're going to connect with a solid line. That's like the one down here just below. And then our third step when we are doing linear inequalities is to shade either below the line or above the line. And I'm going to show you how to decide how to do that in just a second. Okay, let's go and let's actually do an example. So if we're filling in these blanks, the inequality is an example of a linear inequality. A solution to a linear equality in two variables in an ordered pair that makes the statement true. So we're still making the statement true. Given the inequality that has a less than in it, it is not included in the solution. However, if you have an equal to in it, it is included. Given the linear inequality x plus y is greater than 9, the boundary line should be drawn dashed because it's greater than, and it indicates it's not part of the solution set. So what that is saying is that if I connect my points with a dashed line because I have less than or greater than, that the ordered pairs that sit on that line do not make my statement true. Okay, they are not part of the solution set. They're just a boundary, because I need to do some shading. The area where you shade for these linear inequalities are the ordered pairs that make the statement true. That's why it's important to shade in the right spot. All right, so let's try one. So the first step is to graph some points, to plot some points. I like to use slope and y-intercept. So I'm going to solve my equation for y, because that's just how I prefer to do it. So y is greater than or equal to negative 2x plus 3. So my slope is negative 2 over 1, rise over run. My y-intercept is 0, 3. So I'm going to mark those, 0, 3. My slope is negative rise over run, so negative down 2 over 1. Now I'm going to connect the dots. I'm going to do a solid line because I have a greater than or equal to, so solid line. Okay, now for shading you need to get a test point. This is one way to do it. So test point. So find a test point either below or above the line. 0, 0 is an excellent test point. As long as your line is not going through 0, use 0, 0 for a test point. Now, if 0, 0 works, that means it's a solution, and I'm going to shade where 0, 0 is. If 0, 0 does not work, that means it is not a solution. I'm going to shade on the other side of the line, away from 0, 0. So 2 times 0 plus 0, is that greater than or equal to 3? Well, that's 0 plus 0. 0 is not greater than or equal to 3. That's false. So that means to shade away from my test point, which would be up here. Now, that's one way to know how to shade. Now, the other way, if you graph like I graph and you solve for y and you do slope and y-intercept, okay? And so you have solved for y. if you solve for y, follow your inequality. In other words, greater than goes above, less than goes below. So you see, mine was greater than, and I shaded above the line. But that's only if you solve for y. If you're graphing using x and y intercept or a table, that will not work. That little trick only works if you solve for y. Okay, let's do this one at the bottom of the page. I've got negative 3y greater than 5x. So I'm going to solve for y. So I'm going to divide by 3. Now remember, if you divide by a negative number, we have to flip that inequality. So on this one, my slope is negative 5/3. That's my rise over run. My y-intercept is 0, 0 because I don't have a constant out here. So 0, 0, and then I'm going to count down 5 over 3, and then I'm going to connect. Now this time I have greater than, so I have a dashed line. Sorry, it changed to less than, but that doesn't matter. It doesn't have an equal to in it, so it is a dashed line. Now, for shading, I can't use 0, 0 for a test because my line goes through 0, 0. So I'm just going to pick a random ordered pair. I'm going to pick this ordered pair, negative 2, negative 2. Let's just try it. Now, if it works, we're going to shade where that is. So my original equation was negative 3 times negative 2. Is that greater than 5 times negative 2? So negative 3 times negative 2 is 6. Greater than 5 times negative 2 is 10. That is true. So I'm going to shade where that test point is. Right down here where the 2, negative 2 was. And shade nice and shady so you can know that's where it is. Now, my little shortcut, because I had my equation solved for y, I have y is less than negative 5/3 x. I shaded less than was below, so there's below the line. So my little trick also works for that one. Okay, here's one. We've got negative 2x is greater than or equal to 6. We don't have any y here. Let's solve for x. So divide by negative 2. So x, flip your inequality, and that's going to be a 3. Now, if you'll remember, if you have x equals a number, that was going to be a vertical line at that number. So I'm going to mark my 3 on the x-axis. This has a less than or equal to, so that's going to be solid line. So I'm going to draw a solid vertical line. And then we're going to use our common sense superpower. Where are numbers less than 3? Are they going to be to the left of the line or to the right of the line? Well, if you're less than 3, we're going to be over here to the left. So I'm going to shade over here to the left. Okay? So test points work. Now we have one that's a y. So if you'll remember, y equals a number is going to be a horizontal line at that number. So y is greater than negative 2, so I'm going to mark negative 2. Greater than or equal to, so I'm going to have a solid line at that horizontal line. So that means it's solid line. And then shade. Think about common sense superpower. Which numbers are greater than negative 2? Above this line or below? Well, they would have to be above because they are greater than negative 2. So that's how you do just regular linear inequalities that are just, you're doing one line on a grid. Now let's look at doing some systems. So remember, systems are 2 lines. So 2 lines on a grid, and when we were doing systems of regular equations, we were seeing where the 2 lines touch. When we are going to do inequalities with systems, we're going to look for the overlap of shading. That's going to show us our solution. So our solution is going to be where our shading overlaps. So it's going to be very important to do these. I'm going to use some different colors, and hopefully the pen works out because it's kind of been giving me fits right now. So in this first equation, it's already solved for y. I love it. So my slope is 1 over 3. My y-intercept is 0, negative 1. My second equation is not solved for y, so I'm going to add 2x to both sides. So y is less than 2x plus 2. So my slope is 2 over 1. My y-intercept is 0, 2. Okay, so I'm going to go to my first one. I'm going to mark 0, negative 1. My rise over run is up 1 over 3, up 1 over 3. Now, I need to connect him. He had an equal to in there, so I'm going to connect him with a solid line. And I'm going to use my shortcut. Y, it was solved for y. Greater than means shade above. So I'm going to shade above on this line. And now I'm going to go to line number 2, and let me see if I can pull up red. On this one, my y-intercept was 0, 2, so I'm going to mark 0, 2. My slope was 2 over 1, so up 2 over 1. On this one, it was a less than without an equal to, so I'm going to shade with a dashed line this time. And when I solved for y, I had less than, so I'm going to shade below that line. Now, where does the shading overlap? Well, it's kind of like this little pie shape right here. So you would need to make that little piece a little bit darker than the rest to show that that is the solution. Okay? The solution is where that's darker. Right there. So that's how you do a system. You graph each one, you shade each one, you see where the shading overlaps. Okay, let me go back to blue. Here we've got, these are going to be horizontal and vertical lines. X is greater than or equal to 0, so that is I'm going to mark 0 on my x-axis, and that's going to be a vertical line. So I'm going to draw it in here. And I drew it solid because I have an equal. That's a vertical. This is going to be a dashed line because I have a greater than, and it is horizontal. But I haven't done shading yet on the x. So x is greater than or equal to 0 are going to be over here to the right, so I'm going to shade that one. Okay, let me pick up red and do the y. All right, he's going to be dashed, and he's dashed horizontal at 0, and greater than is above him. So there's the above, the y. Notice they overlap over here in the first quadrant. If you remember what the quadrants are in graphing, this is quadrant 1. So my solution is in that corner right there. Okay, here on the left side of the page, they've given you some another example. And so let's just do one more. If I've got, and I'm going to have to draw my own graph, so I'm going to be winging this one. Let me pick up black, and let's draw me a little grid. So I'm just going to kind of sketch this one. You won't be sketching on the computer, but we will sketch on this one. On the first one, I've got y is less than 3. So that is going to be, I'm going to mark 3 on the y-axis. And less than means I'm going to have dashed line. So dash my line. It's going to be a vertical line. Horizontal line. And then shade less than because that's solved for y. So less than. Okay. Let's go to equation 2. Pick up red. I'm going to solve this for y. So subtract x from both sides. So 2y is less than negative x plus 6. Divide all of them by 2. So y is less than negative 1/2 x plus 3. So I'm going to have a slope of negative 1 over 2, rise over 1. My y-intercept is 0, 3. So again, I'm going to be marking 0, 3. but I'm going to be counting a slope of down 1 over 2. Okay. This one also did not have an equal to in it, so it's going to be dashed. So connect them with the dashed line. And once I solve for y, less than means shade below. So I'm going to shade below all the way across. And then where does the overlap start? So the overlap is, let's see, here, here. Just like that, right there. So if you're sketching this, you know, you're just going to make it darker. If you're doing it on the computer, it usually picks it up once you do the shading, and it'll shade it in. And that's how we do inequalities. So you have, the key things are to plot your points, know how to connect them with either a solid or a dashed line, and then decide on where your shading is going to be. I hope you have a wonderful day. I'll see you soon.